Good morning, everyone. Well, the sun's beaming down and it's perfect weather, so I'm really enjoying it, and I'm sure you are as well. Today, we're investigating plants, and the ally is to record observations. Now, you already know that you normally are prepared for these sessions. So, do you have a pen or a pencil and paper? And just remember, if you need to pause the video, do so. You're in complete control. So pause the video because we're about to do a quiz. So our quiz is about plant growth conditions. So what can you remember? So number one, to survive, plants need air, water, and is it A, wind, B, people, C, fertilizer, D, sunlight? Let's move to number two. Write down 3 words to do with photosynthesis. It's been a while since we've touched on photosynthesis. Can you think of 3 words to do with photosynthesis? Number 5. Use the table to answer questions 5 and 6. So which plant would grow the best? Is it A, plant B, or plant C? Look at conditions on the right hand side. A has sunlight but no water. Plant B has sunlight and water, and plant C has no sunlight and has water. So choose the one that you think is the best fit. And then you have question number 6. Why would that plant grow the best? Can you give a short reason for why the plant that you choose would grow best? Let's move on to question number 7. Don't forget, pause the video when you need to. Plants will grow better in which environment? Is it A, where it's dark and warm? B, where it's light and warm? C, where it's dark and cold? Or D, where it's light and cold? And then we have questions 8, 9 and 10 all together. Question 8, true or false? More water is always better. Is that true or false? Number 9, what will happen to a plant that does not get any water? Is it A, dry up and die? B, make new leaves? C, grow faster? Or D, grow slower? And finally, number 10, true or false? All plants need the same amount of sunlight, water, and type of soil. Remember, you can pause the video. I'm going to continue, and you can restart when you're ready. So I'm going to move on. Okay, we're thinking about plant growth conditions. Now, why would we be thinking about that? First of all, if we go back some time now, 3 weeks ago, we talked about waltz, W-A-L-T-T-S-N. So can you remember what W stood for? Can you write that down now? What does W stand for? I'm going to reveal the answer. Water. Can you remember what the letter A stands for? I'll count to 5. You've got 5 seconds to write down an answer. 1, 2, 3, 4, 5. Air. What does the letter L stand for? I'll count to 5 and then reveal the answer. 1, 2, 3, 4, 5. Light. Some people may have written sunlight, which is correct as well. What does the letter T stand for? I'll count to 5 and then reveal the answer. 1, 2, 3, 4, 5. Remember, pause the video if you need to. So, temperature. And when we think about temperature, we have to also remember it has to be the right temperature. If it's too cold or too hot, some plants will not be able to survive. They won't grow to be healthy if the temperature is not just right. The second T stands for, I'll count to 5 and reveal the answer. 1, 2, 3, 4, 5. Pause the video if you need to. Time. Plants take time to grow. They don't suddenly change from a seed to an adult plant overnight. It takes time for the seed to grow into a seedling, and then that seedling grows into a younger plant, and then that younger plant gradually becomes an adult plant. Let's move on to the letter S. What does the letter S stand for? 1, 2, 3, 4, 5. S stands for space. Plants need space to grow. If they're too close to other plants, they may end up fighting over all of those things above, such as water, air, light, and temperature. So space for plants is important. If they're too crowded, they're not going to grow into healthy plants. And finally, what does the letter N stand for? 1, 2, 3, 4, 5. N stands for nutrients. So those conditions are important if a seed or seedling or young plant get to grow into healthy adult plants. Okay, let's look at the images on the right hand side. So we have here, observe what changes have taken place. Now the first image on the top left is what we call the control. In that container is cress, and that cress has all the ingredients it needs to grow to be healthy. So it has water, it has air, it has light, it has the right temperature, it has time to grow, it's got the right amount of space, and it has the nutrients it needs in order to grow into a healthy plant. So that control is what we're going to compare with the next examples. So on the right hand side, in the middle and on the far right, we have the cress. Now this cress was put in a bowl and not given any water. Can you see the changes that have taken place? What's happened to the cress because it's not been given any water? It's had all the other things that the control cress has except for water. So you can see that the cress on the far right hand side can barely be recognized as cress. It's all dried up and it's pretty much dead. Let's look at our next example. In the bottom we have cress that was put in a dark area. So it had water, it had air, it had reasonable temperature, had space, had nutrients, but no light. Can you see the difference between the cress without light and the control? Look at the change in colour. There's a big difference in colour. And then we can look at the far right hand side. We've brought it out and comparing it to some other cress. That one looks a little bit green. It's been out in the light a bit now. It's recovering. But if you don't give the plant enough light, it's going to lose its colour. And also, the stems are going to grow really long because they're searching for sunlight. Let's move on. So for a plant or a young plant to grow into a healthy plant, it must have the right conditions. So we can see on the right hand side, we've got the control and we've got the cress that was not given any water. Look at the difference between the control and the cress that had no water. Now we have on the left hand side the cress that had no sunlight, not as green, it's quite tall, and because the stems are growing really long because they're searching for sunlight. And then on the right hand side at the bottom, this cress was put in the fridge, so the temperature was much cooler. And you can see that the cress that was put in the refrigerator, although it looks very green, it hasn't grown as tall as the control cress. So we can see that if we change the conditions for plants, different things can happen. Now unfortunately, the cress that was not given water is not going to survive. It will not be possible to bring that cress back to life, but we could definitely give the cress that had no sunlight and the cress that put in the fridge, if we put it back into the normal conditions that healthy plants need, they would recover. So let's move to our next phase. You may have remembered that in week 1 we measured the height of different plants. So I've been keeping a record of the height of these plants. So in the top left hand side we have the coriander and the basil. So on the right hand side we have coriander, and on the bottom we have the basil. Now you will notice shortly that there is a change in the growth of these plants. So we've got the mint that I've just uncovered, and we can see that from the beginning the mint's much shorter, and then on the far right hand side we can see that the mint has grown much taller. So I kept a record of all the data. So here we're going to record the growth of the mint over a period of 4 weeks. So the ally is to record our observations. So I put the dates. On the 28th of April, the mint was only 8 centimeters tall. And then on the 5th of May, I remeasured, and the mint had grown to 12 centimeters. And then a week later, the mint had increased by 5 centimeters, and when I measured it, it was 17. And then a week later, on the 19th of May, that's today, I measured the mint again, and it is 22 centimeters. So we can look at those heights and we can see that the mint has continued to grow. And if we see that kind of growth, we can assume that the conditions for the mint were ideal. Now, how can we record this information? Well, we could record the information by constructing a bar chart. So I have a title, Growth of Mint Plant in Centimeters over 4 weeks. So I've constructed a bar chart to show the increase in height of the mint plant over a period of 4 weeks. So we've got our 4 bars. Each bar stands for a different week when we measured, and the measurements are in centimeters. So you can see that we have a title, and on the left hand side you can see that we've got the numbers on the left hand side stand for height in centimeters, and the numbers on the bottom stand for the weeks that we recorded the height of the mint. Okay, how else could we, sorry, I've got to go back one. So we could also construct a line graph to show that same information. So we've got a title again like before, the growth of the mint plant in centimeters over a period of 4 weeks. So on the bottom, the numbers stand for the weeks that we did the measurements, and on the left hand side we call the y-axis, the numbers stand for height in centimeters. So we can record our observations after we have written them all down over a period of time. Now that means that we can draw conclusions about our observations as well, which brings us to the tasks. So once again, you can go to Grange Online Learning, Year 3, Science, Investigating Plants. And you have 2 tasks. And the 2 tasks involve the data we used for basil and coriander. So you have to write a conclusion for both and construct a bar chart for a basil plant and a line graph for the coriander plant.